Well, today we're in Shafter. We're at Sequoia Elementary School, and today we're here to... All right, today we're at Sequoia Elementary School, and with me now I've got fifth grader
Roman.
There you go. You know what? You threw me off there for a second because it's the kids up here. Roman, how are you?
Good.
Okay, let's go ahead and get started on the problem. Now, you said that you have not started working with fractions yet, right?
We worked with some fractions.
A little bit.
Yeah.
So we're going to go ahead and we're going to just kind of extend a little bit possibly on what you've already worked on. So if I have 2/3 and 2/3,
Okay.
how many thirds do I have?
You have two.
I have 2 there and I have 2 here. So altogether I have...
What? No.
When the denominators are the same, we can leave that and we just add straight across.
Okay.
So we have 2 and 2 is
4.
4. So if you have 2/3 and I have 2/3, altogether we have 4/3. And we can add those up because the denominators are the same. Here, the denominators are not the same. So what we need to do is we need to turn these into like denominators. So think about what is something that 3 and 4 will go into.
12.
Perfect. All right, so why don't you go ahead and put 12s down here on the denominators. Oh, on the bottoms. There you go. So we're going to turn these into 12s. That way they have a like denominator now, okay? But we turned this from a 3 to a 12. How did you go from 3 to 12?
Times it by 4.
Perfect. So whatever you do to the bottom, you need to do to the top. So the numerator, you're going to multiply by 4 as well.
Okay. So
what will
4
that
times
become?
2 is 8.
Perfect. Go ahead and make that the new numerator. And what about this one?
4 times 3.
Okay, so what do you think you have to do now?
Times 3 by this number.
Perfect. All right, now, just like we did here, go ahead and continue solving that problem.
16.
Almost.
Not 16.
No. 8 and 8 is 16, so what's 8 and 9?
8 and 9. Oh, 17.
There you go. 17 over what?
17 over 12.
Perfect. Now that is an improper fraction because the numerator is larger. So we're going to go one step beyond this. How many times will 12, well, let's do it with this one over here first. How many times will 3 go into 4?
1.
1. So that's going to be a whole 1. If 3 goes into 4 one time, how many are left?
1.
1. And the denominator stays the same. So 4/3 is the same as 1 and 1/3. Because 3 goes into 4 one whole time, and there was only 1 left over. So let's try this over here. How many times will 12 go into 17?
1 time.
Okay, so go ahead and make your whole number 1. How many are left?
There are 5 left.
Perfect. So where are you going to put the 5? Nice. And what goes on the bottom?
12.
All right, Roman took the step from not even doing some fractions, got that stuff underway, but now we're going from unlike denominators, converting them, improper fraction to mixed number. Roman, nicely done.